Hey Emily, how are you doing? We got Emily in the chat. I was gonna say hey, and then I was like, I was getting Mubot going. I was like, oh, I gotta get Mubot up. So Mubot should be booted up. Mubot, are you awake? Mubot is still waking up. He goes to sleep and then he has to wake up. I don't know. I think they updated the thing because it took longer to load Mubot. Mubot is in the chat. Mubot, you awake? I'm not typing anything. I didn't type anything. Mubot, you here? Mubot? Mubot? How's everyone doing? Mubot? Mubot's been acting. He's been slower lately. How are you doing, Emily? He is awake. Mubot is awake. Maybe it just takes a while when Mubot starts up. But how is everyone doing? What questions are there? We will just answer some questions about class. We have one more class to do today. Both 201 sessions were completely awesome. The last 201 session we did was just, I was just blown away by the interaction. Then I went and got some birthday cake. Go off screen right there. Just completely go into the void back here. I'm on a sugar high. Just so much sugar. I just wanted to ask what we have to do before next lecture. Great question. Let me bring that up. I can bring that up in the background right here. So what would I do before next lecture? Are you in 320 or 201, Emily? I think 201. Correct me if I'm wrong. 320 or 201. And really good question there. What should I do before the next lecture? What should I do before the next lecture? Which class? 201. Okay, awesome. Before next class, 201. Okay, number one thing, connect my Pearson to Canvas. Everyone to spell my Pearson is fine with me. Connect my Pearson to Canvas. Still not a word, but it is a word. Let me drop that link in the chat right here. So if you're watching, I don't want to be like, go find the video. It just helps if I put the video link in the chat. That makes life a lot easier. And you can hear the nice soothing music. Because I had to, there we go. Hey, what's up, A8? I was telling people, I was like, you can use whatever name you want. I mentioned your name. I was like, we had A8 Ballin in the chat. So good to see you. I reset the points. Your hours still exist. But if you check out your points now, you lost your legend on the Discord, but your points have been reset. Because that's going to be the easiest way for me to track points. I'm not going to destroy the point economy. Mubot has been, thank you, Mubot. I'm already at gold tier. And I also added in, if you look at it, it now tells you how many, bonus points you're getting. So, 2 seconds. We are good. So, it tells you. We've also got new effects, new things this semester. I'm back. Oh, I'm so sorry. But look, you've got 46 hours. That's insane. So, oh, but you still have your Stat Nation Hall of Fame. That's interesting. That's interesting. I wonder if that'll reset. That's interesting. I'll have to make sure people know that if they're in another class and they got points, because I'm hoping that resets too. Sorry to take away your... Oh, it has your original Stat Nation Hall of Fame. I bet it'll update now, though. See, it doesn't tell you your points. So it doesn't say how many points you have. But so, Emily, I would connect in Canvas to my Pearson. That'd be the first thing I would do. The next thing, we'll go kind of class-specific right here. Attempt homework 1 and quiz 1. I would attempt homework 1 and quiz 1. Oh, no, it's totally fine. Yeah, if you want links to like your former student, just email me, be like, hey Brian, can you send me links? I'd like to swing by class. You're welcome to, and I'll send you those things so I can say like, oh, 320 student. Oh yeah, because we were talking about you showing up to talk. That's all right. Are you free at 6:10 your time? Oh yeah, 4:00. Yeah. If you want to swing by to talk to students later tonight, message me on Discord. We'll get that going. But no, you're one of those students. I was like, yeah, if you want to swing by, because I messaged a few, and I'm honored if anyone swings by to like just talk to them. And man, I just tell you, like, it's so much fun the first day. So much like everyone's getting hyped because people haven't seen this type of thing that we do, and I'm like, let's show them what we can do. The next thing to do right here after we attempt homework 1 and quiz 1 is join Discord. Discord's 100% optional. 100% optional. But if you notice, A8 was able to talk to me really easily on Discord, like, what chapters should you read? So what I would do is if I was in the class, there's Brian in the background right there. Stop talking, Brian. I would go to the modules, and I would look over the notes. So before class, I would go to stats start here, and I would just kind of review them. If you spend like even just 10 or 15 minutes, like just reading through them, reading the highlighted words, that'll give you a mindset. I wouldn't really read the chapters, they're longer reads. They might also include details we don't go into. Like some chapters have like additional concepts we don't cover because we just don't find them as beneficial and we have limited time to teach during the semester. So the slides are what you're required to learn. I mean, like required as in it's what we're going to test you on. So the slides are a better kind of cliff notes of what we'll be teaching. So I would go to the slides right here and I'd review slides. I think that's a good objective too. And we'll put that as number 3. Review slides before class. You don't have to do these things, obviously. I'm going to go to the main screen. You don't have to do these things before class, but I'd review over like chapter 1, maybe chapter 2. Just seeing the material multiple times is how you learn things. If I tell you something like a p-value is the probability of our results or results from our stream happening by random chance variation given that the null is true, you're going to be like, what? But by the end of the semester in 320, I can usually have people give me something similar to that. I'd be like, explain to me what a p-value is. And they'll be like, well, it's a probability we get after we do a test that tells us the likelihood of our null being true or of seeing, that we get a value as extreme or more extreme than our value given that the null is true. I've memorized what I say, but they'll be able to kind of go through and explain these concepts. But it's because we say that like 50 times in class, and I don't just rattle it off like that. To be very, very explicit, what's up, Dan? I'm going to try to work on that Vol TV channel. Whoa, what is the Vol TV? Do I know about that? I'm going to try to work on that Vol TV channel. What is that? Dan, tell me more details. I feel like I should know that. I feel like you're telling me something we've talked about. Have we talked about this? When I talk about p-values, and I go over it slowly, I mentioned that a p-value is when we have a null hypothesis, which is a starting belief, like some value is true. And so if we were to throw a dart at this board, it'd be more likely to hit the center of the board. Like that's the kind of sweet spot of the board. But when we talk about a p-value, we take our observed results, which is where we have our observed over here, and then we look at the probability of a result as extreme or more extreme given the null is true. So does this look like a highly likely thing or a not so likely thing? Awesome, so great. Thank you, Haslam Fridays. We love Haslam Fridays. Does this look likely or unlikely? Like with how much of the curve I've shaded, does that look likely or unlikely? And this is how I would teach the concept. And we go over it multiple times. We're not just going to say the p-values, but it is the probability of our results or results from our stream. So does that look unlikely or likely? And this is why you need to hear things like 10 times, because that's the p-value right there. That is our observed results. That's the null hypothesis. Everything inside of here is a result that could occur by random chance given the null is true. Like this result could occur, this result could occur. And what do I mean by these results could occur? Like let's say Brian is truly, like Brian can really run a mile. His best mile Brian can run is 6 minutes. Brian can run a mile in 6 minutes. That's like, if Brian were to go out and run a mile, his average time is 6 minutes. That's the truth. And we are assuming this is the truth to begin with. We're saying, well, if Brian is a 6-minute mile runner, how fast would you expect Brian to run his miles? If Brian is a 6-minute mile runner, how fast would you expect Brian to run his miles? See you, Dan. Let's talk about sports, about the volunteers. Tell me more, like email me more about that or tell me more on here. We'll see. Hopefully Emily's watching around. If Brian is a 6-minute mile runner, how fast would you expect Brian to run a mile? So the key thing, it's not your question. If Brian is a 6-minute mile runner, how fast would you expect Brian to run a mile? If he is a 6-minute mile runner. So Brian is a 6-minute mile runner is what we're assuming is true. Like, oh yeah, Brian is a 6-minute mile runner. So I'd expect him to run his mile in around 6 minutes. And you really phrased it a good way. Like, would he run it exactly 6 minutes every time? No. We'd expect his time to be somewhere around 6 minutes, like somewhere kind of near 6 minutes. Does that make sense, Emily? Like, we're not saying Brian will run his mile in 6 minutes. We're saying we would expect. But isn't there variation? That's what this curve is showing us right here. It's showing us the variation around 6 minutes that we would expect. So let's do 2 observed results. Let's say we have an observed result. We have 2 different observed results. We have an observed result here. Now this is like Brian ran the mile in like 6:05. So, and we're not going to like do the statistical test. We're just going to talk about it theoretically. This is one observed result. Brian ran a mile in 6:05. And then another result is Brian ran the mile in 7:10. Now, which of these results seems more likely given the null is true? Because someone says, no, Brian, I don't think you were that fast. I think your time is higher than that. Someone has the alternative that Brian takes more. Which of these results would be more in line with the null? Like, which of these seems more likely given the null is true? You guys making sense? You're looking at an advanced concept right now, Emily. Like we're on the third test material right now. So we're doing a hard concept. 605 is more in line. Yeah, you're like, that seems more probable. So when you look at the p-value for this result right here, the amount of area shaded under curve is the probability. And let's put this in context. I'm going to write this out. So the p-value, we're just having some fun learning an advanced concept. So the p-value is the probability of our result or results more extreme happening by a random chance given the null is true. So in context, the probability of Brian running a 6:05 mile, which was the observed result, or a mile slower than that, given by random chance, given Brian is a 6-minute mile runner. Okay, let's put that on the screen with it. Let me decrease font. Okay. I think that's viewable. I wish I could just make that a little bit smaller. Okay. So we got pretty complex right here, but would you say the probability of this is high or low? And I think you pretty much did. The 6:05 seems like a probable result, but the 7:10 seems like a very not probable result given I'm a 6-minute mile runner. Like this doesn't seem, if we look at the p-value, we wouldn't really be shading much of the curve. We'd be kind of off the curve. We'd be like, ooh, this result over here doesn't seem likely. It's very small probability that we would see something this high or more extreme, because this is the result, and this is a result as extreme or more extreme, like we're shading as extreme or more extreme. So if I ran my mile in 7:10, this is the last thing I'm going to comment on this. What would you do to your belief that I'm a 6-minute mile runner? If I ran my mile in 7:10, what would you do to the belief that I'm a 6-minute mile runner? I wonder if you say the exact word we use in statistics. What would you do to your belief that I'm a 6-minute mile runner? If you saw me run 7:10 and you were able to do an analysis like this, what would you do to your belief that I'm a 6-minute mile runner? You're like, oh, I just saw Brian run a 7:10. That doesn't seem likely that he's a 6-minute mile runner. Like with what I observed, it'd be very improbable for him to run it that slowly given he's a 6-minute mile runner. What would you do to your belief that I'm a 6-minute mile runner? I figured it'd be fun to teach a concept. Yeah, you would come up with you could actually create a confidence interval around this, and you could believe like it's an aberration. You could say, well, that's just an outlier. You could think, well, is it an outlier? Or you can also just reject this belief. Oh, how did that change to white? That is so weird. You could reject that belief. What would you reject the belief that Brian is a 6-minute mile runner if you saw me run it in 6:05? If you saw me run it in 6:05 and someone's like, well, Brian didn't do it in 6 minutes, would you reject the belief then if you saw Brian run the mile in 6:05? I run my mile in 6:05. Would you reject your belief or not reject it? That I'm a 6-minute mile runner. Would you reject it or not reject it? Would you be like, I reject that Brian's a 6-minute mile runner. He took longer than 6 minutes. Or would you say, well, 6:05, I mean, there's variation around 6, so maybe he is a 6-minute mile runner. This seems possible given he's a 6-minute mile runner. Would you reject it or not reject it? Don't worry. You are learning third test material. You're kind of, and this helps. You wouldn't reject it, exactly. And that's the phrasing we use. We use, I would not reject it. My pens are acting so weird today. We would say, I do not reject it. And we're not saying we know he's a 6-minute mile runner. We're just saying we don't have evidence to go against it. Does that make sense? Like that's how statisticians talk. We would say, it's not that I know he's a 6-minute mile runner. It's saying right now we don't have good reason to believe that he takes longer than 6 minutes. Like this 6:05 could just be random variation. Maybe Brian was a little slower that day. You know, there's variation in how fast people run. So it seems possible that if he ran it in 6:05, that he is a 6-minute mile runner. So we're talking about here the probability of observing 6:05 given Brian is actually a 6-minute mile runner. Is this making a little more sense? And this will help when we actually cover it, like like in the notes. And this is how you get to see kind of how I teach topics. We'll do like on slides. Awesome. Great job, Emily. Like amazing work on this. Yeah, I really appreciate it. You know, like, you know what I'm gonna do? I'm gonna do it. All right, we'll just do it. Ready? I'm gonna do a bonus question. Maybe I'll do this during office hours too. Let's do a bet, and I'll do like 3 points. 3 points. We'll do 1 is yes, or 0. 0 is yes. Make sure to do 0. Let's do 10 free points. I'm gonna try to like keep the point economy not destroyed this semester. So if you want points, just do bet 0, 10. And if you do that, you should get points, especially if you're watching right now. So if anyone else is watching, you can bet points. And you see I already bet, and I'm gonna get points. So I just want the right 10 points. I'm gonna try to do more betting during class so that way people can interact and get points, because I know people like the points. But if you want to do that bet, Emily, you can get points. And yep, I think it says there's 2 bets. Why do I not see? Is Mubot like in the future? I don't know. You know what? Maybe chat is on a tiny delay. Maybe YouTube changed it, but Mubot saw that. What other questions do you... I have to stop the betting. What other questions do you have, Emily? You and I get points. Yay, points. But I really appreciate, like, ask questions, you know, let me know any questions you have. There's the... Maybe check out the visualization assignments. We can talk about whatever. Visualization assignment. Check out visualization assignment 1. Ask you to take a random sample. If you have Jump downloaded, so let's put a pre-step right here. Download JMP. Let me go get that link and put it in the chat. So if anyone's watching this video in the future, they can just look at the chat. They don't have to be like, hey, Brian, where's the video? So I'm putting a playlist in the chat right now, and the playlist has Mac and PC. Download Jump. Just make sure to go to the next video if you're looking for the next one. But there is the download Jump link for number 5. We also put the connecting to my Pearson earlier, so rewind the tape. You don't have to register. When it brings up the register button, just click wait to register. It'll, when you finish your work, it'll have like a wait button right here. That's my handwriting. And that's why I don't write much. It'll have a wait button and just click wait to register. You never have to register. Yeah, great question, Emily. Yeah, that's, and so just save you a moment right here. Just like, I'm not registering. I'm not registering. I have, like, eventually I'm going to cut my hair, but I just think, what if I didn't cut my hair for like a year or 2 and I like donated to Loxella? My hair is already driving me nuts already. I like my hair, but like it just gets in my face and I'm trying to teach and I'm like, I can't see, looking around my hair right there. So, just I didn't think I'd have shoulder length hair. I had it in high school and then I was like, I'll probably never grow my hair out that long again. And then the world caught on fire. 2020. So here's Brian's huge keys for success. Brian's how to do well before next class. And every Monday, don't worry, you can always ask questions. Every Monday I'm going to start, like this is my plan. Every Monday I'm going to start office hours. I'm going to take questions, of course. But every Monday I'm going to say, like, here's what I would do this week. Like, here's what's coming up this week. Things could change. Like, we could add something. We don't want to do that, but I could be like, oh, well, we have to do this thing. I might forget something. But generally, if you watch start of Mondays, I'm always going to be like, here's my advice for like the start of the week. But you can always jump in and say, hey, Brian, what should I do now? And especially right now, it's just chill time. And we'll definitely, if you have questions, keep asking. Start of the semester, things are usually a little slower, more relaxed. And then as we start having a bunch of assignments, people will jump in and be like, hey, can you work this one? Can you work the rain, no rain? Can you work the guy with the 2 routes? What else is there? The baseball, football question. It's a lot of really good questions. We will see what questions are there. What questions are there? Let's see. I'm like thinking of what to do next. We haven't coded much this semester yet. Coding. Cat paste. Coding is awesome. There we go. Coding. We're coding. Is Kahoot going on all day tomorrow? It'll be, you know what? I should set the time for the Kahoot. Let me look at my schedule. Let me go ahead and schedule this. Okay, I'm going to schedule the Kahoot right now. I'm going to schedule Among Us. Okay, so let's you think we should do a morning or an afternoon Kahoot? Should we do a morning or afternoon Kahoot? When should we do the Kahoot? The morning or afternoon? I am free until like 12:30 your guys, or free until 12:30 tomorrow morning. And then I'm free after like, gosh, I hate time conversions. It's not that hard to do. 3:30 in the afternoon. And I have the Kahoots already written. Hey Brian, where can I find the past streams? I need to check something out for the knitting assignment. Yeah. Let me send you a really good link on this, Emmanuel. Are you looking for a class stream? Let me explain this real briefly here. Great question. So if you're looking for past streams, if you go to the YouTube channel, and my gosh, we've already gotten hundreds of people. Got 4 people watching right now. Really great. Just jump in, ask a question. Appreciate that. We're just kind of riffing right now. If you go right here, you can see past live streams. If you're looking for the class though, like if you're looking for one of our class links, and let me get you, I'm gonna get you a video here that'll help a lot. Did I have to find this video real quick for you. And I need to send this out later. Okay, I can actually see my videos again. I'm gonna put something in the chat. Okay. This video is called Getting an A on Assignment 0. Save it. We want to explain through this. Okay. So is it unlisted? No, it's not unlisted. My channel got weird. Okay, so Emmanuel Assignment 0 help. So here's Assignment 0 help right here. That should bring you to the Assignment 0 video. The playlist for our class. Give me 2 seconds. I'll bring out the playlist. When you go to your class, if you're looking for the old streams for the class, you can go right here and go to whichever class you're in, like BAS 320, Monday, Wednesday, Friday, and then go to the Watch Class Live button. And under the Watch Class Live, it'll bring up the playlist. So you can see the different videos right there. So that's got it right there. That has it. Okay, what questions are there? What questions are there? We will see. I'm trying to think what time would be a good time to do the Kahoots. I don't know. We could... You're welcome, Emmanuel. You're welcome. You are welcome. We will see. I'm trying to think what other questions. I think Kahoot tomorrow at maybe, should we do it in the afternoon or the evening? And then we want to play Among Us. So have some fun with like Among Us. Try to figure out a good time. Let me go look at my schedule again. Office hours. Think, let me schedule this in for 4 p.m. your guys' time. That's what I told people today it was. Let's do Among Us then. Let's do Among Us in the afternoon. And let's do Kahoot in the morning. Let's do like an 11, let's do an 11 a.m. Kahoot. I can get up by 10 a.m. I'll send out a link tonight to it. I'll send out a link tonight. And I gotta remember not to call it Kahoot. So we'll do that right there. You're good with the afternoon. Hey, Kennedy. So good to see you here, Kennedy. I just saw you in the chat right there. I was looking at some stuff. Emily, you get to pick. Emily, do you think we should do... When should we do Kahoot? In the afternoon or should we do it in the morning? Which would be better? We're going to do Among Us one time. So we'll do like Among Us at one time and we'll do a Kahoot another time. And usually I'm more free on Fridays. But what would be a better... Should we do Kahoot in the morning or Kahoot in the evening? So the choices are, one of them will be at 11 a.m. and one of them will be at 4 p.m. So 11 a.m. or 4 p.m., which one? So we're going to have 2 streams tomorrow at 11 a.m. and 4 p.m. And so which one, as long as nothing goes too crazy? Evening Kahoot? I'll switch it on my schedule then. So Emmanuel says evening. I'd put it to a vote if it was, maybe I'll have the afternoon class vote also a little bit, but evening Kahoot might be better. I'm good with either. And then Mubot now. Mubot actually, I've updated a lot, Kennedy. You can check out your points, Kennedy. We've redone the points a little bit, but we've done a lot of updates. So Jacob, which one do you want, Jacob? You want you're good with either, maybe? So it looks like my points are just going crazy. I've already got 1 point on my exam, or my total grade. So 1 point on my grading average right there, which is awesome. Maybe we'll put this to the Kahoot. It's better if more people attend the Kahoot. I feel like the Kahoot will have more attendance, and the like if it's done in the evening, and Among Us is just for fun. So we could play like 2 or 3 games of Among Us, and that can end early because I have a departmental meeting. Like, I mean, not end early. Evening is cool. I'm good with either. Cool. Looks like Jacob's saying some evening right there. What questions? And so thank you so much for everyone watching. We're just answering questions right now. What questions do people have? Kahoot is better in the evening. I agree. 4 p.m. is usually good. I mean, maybe we could move it a little bit. I don't know. I like, it's nice to have like your Fridays off. Like, like as in like, if I did it like 9 p.m., my fiance would be like, let's watch a movie. And I'd be like, I have a Kahoot at 9 p.m. I mean, I like doing Kahoots, but then I also want to watch, movies with my fiance or something, or like eat some pizza and stuff. So I wouldn't want to, because, I want to, see my fiance like Friday night. So, yeah, so I think 4 p.m. is good. That way people also can, like play the Kahoot, and then we have kind of the evening off. So I think that's a good time frame to do it. 4 p.m. That's like the end of the workday, like 4 p.m. to 5 p.m. I like that right there. It's 3 p.m. my time. It's weird being in a different time zone. Sometimes I'm like, wait, are you guys an hour behind, or I'm an hour ahead? Where am I? I don't even know. I don't know. What questions are there? I might answer emails here in a little bit. Does anyone have any questions right now? We have the Kahoot scheduled for tomorrow. We have the Among Us scheduled for tomorrow. Among Us will be tomorrow morning at 11 a.m. Central for the win. Oh, thank you so much, Emmanuel. Yeah, thank you. I really appreciate that. I literally got my Appalachian State mug right here. I had ice cream cake. I was like, I better not have ice cream cake all over my face. I don't know how that would happen, but today for lunch was ice cream cake. Now it's ice cream cake soup. Never eat on stream. Such a bad idea. Don't do that. I'm doing all that. You don't do that. West Tennessee Central. Awesome. Knoxville's pretty close to it. You know what's so funny is I think I went like to the edge of the next time zone. So, like Knoxville, if you go all the way to, what is it? I can't even think of it. I think Marrowsville. Marvel is in Central, right? I had I've had a few friends from Maryville, and everyone, if you're from Maryville, everyone says Marvel, or at least, am I correct? I don't want to say everyone says it, but one of my friends, MG Bailey, he would say, he's like, I'm MG Bailey from Marvel, and I was like, where? He's like, everyone calls it Marvel, and so hopefully someone in the chat's like, yep. So get some confirmation right here, or like, nope, and I'm wrong. So we're pretty close. I did misspell canvas. We're pretty close to the next time zone in Tennessee. So you'll hear my accent come out. I'll say like water or like daughter. Yeah, they say Marvel. Like my O's and stuff can be kind of interesting sometimes. And it's just how people say stuff. If you go back 200 years, everyone's going to talk differently. So there's just how dialects change over time. So it's pretty interesting to just hear the differences. Most of TN is Central. Yeah, exactly. TN is such a long state. Tennessee, I miss Tennessee. It's such a long state. I mean, I basically traveled, I think I went down and over to get to Texas, but you can just go like straight across and then down. Like you travel a lot in Tennessee. I think I was in Tennessee for like 5 or 6 hours. So is there a Memphis, Arkansas? Because Memphis, like there's like Memphis, Tennessee, and then Memphis, I'm totally getting or is there, it's in another state. There's like another state. It's kind of like Bristol. Bristol is at the other end of Tennessee. So wait, we got these like cities that go into the other state, but like it's another state city. So am I correcting me on my Tennessee geography? But Johnson City's East Tennessee. I obviously know that. And Memphis is West Tennessee. And we're just such a long state. It takes 5 hours to get from Knox to my hometown. And yes, Memphis is in 2 states. Exactly. And so is Bristol. Bristol's in Tennessee and Virginia. And I didn't know that till I was traveling that Memphis is in 2 states. So I was like, what the heck? I was like, now entering Memphis, and I can't even think. I'm so bad with geography. I'm gonna like say something. Now I'm entering Memphis, Texas. I'm like, you're like, wait, Texas and Tennessee don't connect. Where am I? But yeah, I'm so bad. My friends used to laugh because they'd be like, Brian, what state's above Texas? And I'd be like, Vermont, and they'd be like, you're joking, aren't you? And I'd be like, I know it's Oklahoma. I know it's Oklahoma. And then I worked as an archaeologist, and I got better with where my states are at because I traveled around the U.S. some. So I know Oklahoma's above Texas, but I used to be really, really bad. It helps to travel. The U.S. is such a big place, but it helps to travel. And you're like, we just pick a state like Connecticut, and I mean, I can see where it's at, and I'm just like, I don't know. I mean, but other than traveling, what information, like how does knowing where the states are at help you in your daily life? I think things like algebra and statistics. So I'm getting back on topic right here as we kind of just like talk about things. I think algebra and statistics help you a lot more in life. Like I think those can like give you insight into how the world works. So when you learn how to do statistics and algebra, you can make data-driven decisions. And I mean, it's good to know where every state is at to be like, here's a blank map of the U.S. Where's South Dakota? And everyone's like, "Yeah, I don't know. It's, top west, but it's not going to help you in your daily life to know where South Dakota's at unless you're doing some sort of like, I guess supply chain major, you should probably decently know locations of states. But we've got maps and stuff. It's pretty, with the information access we have these days, you could, type into Google routes and stuff like that. So, and then the more you use it, you'll eventually be like, oh, well, it's right here. It's below North Dakota. No duh. But yeah, what questions are there? Let's take some questions. I've just been riffing about the states and random knowledge you should have that I don't have. What questions are there? What questions are there? And great job on the points. We've already got some bronze tier members. I actually just reached gold tier. So I've done like 4 or 5 streams. So if you attend about 4 or 5 streams, so you could track like how many points Brian has over the course of the semester, I've already reached gold tier, and I think I did Ask Me Anything. This is the 3rd office hours stream. I've done 1, 2, 3 classes, and I think that's it. So I'm on stream number 7, and I'm at gold tier. So if there's 2 streams, if you just attend class, that's a little less than a month to get to gold tier. So does everyone kind of see how the point economy works? In a little less than a month, so you'll be like mid-February, and you'll probably be at gold tier if you attend class every time, like with the amount of time you have in class. So attending class can get you'd be at gold tier by mid-February. And then it takes a little longer each time to get to each tier level. So about a month is about 1,000 points. So yeah. And so that's why I tried to calculate it correctly, that if you attend class only, you will get enough points. I don't want people to be required to come to office hours, but you can come to office hours, ask questions anytime. Technically, someone could just attend office hours and probably get all the points. It's a different experience coming to office hours. Like this, for those who are in class, does it seem easier, Morgan, right now to ask questions? If like you have a really important question, and you're like, I really want to know, Brian, how do I do this? Like, hopefully this seems a lot easier. Like this is like, you can easily be like, hey, Brian, do this. And it's a lot easier. Office hours are basically open to me helping students. Like sometimes we have an agenda like around projects. We're going to work the project. Around tests, we're usually going to review for tests. Yeah, it's really easy, as Morgan says. Yeah, so there's never any true agenda. Like if everyone came in and they were like let's say the test is coming up, and I'm like, oh, let's review for the test. And everyone's like, no, we need help with this homework. I'd be like, well, the test is tomorrow and the homework was due last night. And if everyone was like, let's do the homework again, I'd be like, if they all voted for it and they're all here, I'd probably put it to a vote. I'd be like, well, I think this is better, but it's your guys' class, so I let you guys pick what to do. Thank you, Morgan. I really appreciate it. We'll go for like another 5 minutes, see if there's any big questions. It's so funny. One semester, and I learned that like the first week, even, so when I do office hours in person, we usually have anywhere from 5 to 50 people show up in person too. Like usually it's a right skew distribution. Let me explain what right skew is. So here's a new topic. So if you're in Stat 201 or if you're reviewing in 320, we should know a famous saying: right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. Okay, right to the high, left to the low, whatever way the tail goes. What does right to the high, left to the low, whatever way the tail goes means? It means if you have a distribution right here with numbers going from 0 to 100, or if you have a distribution right here with numbers going from 0 to 100, one of these distributions is skewed to the right, one of these distributions is skewed to the left. Which of these distributions right here, distribution 1 or distribution 2, is right skew? And I'll give you a hint. We'll draw our little monster guy. Which of these distributions right here is right skew? Right to the high, left to the low. You're right, Emily. Excellent work, Emily. Right to the high, left to the low, whatever way the tail goes. The tail on that distribution, or the outliers, are to the high side. If you look at the tail of the little monster dude we drew, that guy looks mean. That guy looks all happy on the left. But the way the tail goes of the distribution, right to the high, left to the low, whatever way the tail goes. So you can see right here, this is skewed to the left because we need to erase that now. And this is also known as negative skew. Like right skew is positive skew. The tail goes to the high side, and left skew is negative skew. Sometimes people say positive or negative skew, but does this make sense here, Morgan? This is like right skew, left skew, positive skew, negative skew. We call it right skew in the class, but if you're in another class, they might say positive skew, and it's just right skew to the high numbers. So when I say right to the high, it's pulled out to the high side. Left to the low, the tail is pulled out to the low side, the tail of the distribution, like the slim part of it. That's like the tail of it. Awesome job, Morgan. And the good news is we never have to figure these things out by hand. We made a distribution in Stat 201 today. Who can tell me if this is right skew or left skew? Is this a right skew or left skewed distribution? Is this a right skew or left skewed distribution? Right or left skewed? And once you have this concept down, you're like right to the high, left to the low, whatever the tail goes, whatever way the tail goes. Is right skewed or left skewed? Little 201 extra concept review right here. It's right skew. So should the number, when I calculate the skewness, which we never calculate skewness, we just talk about it right skew, left skew. When I click the skewness button right here, will it be a positive or negative number? When I click the skewness, will this be a positive or negative number? And this is additional things. You only need to know that this is right skew for the test. That's the only thing you need to know for the test. But we're learning like right skew is also positive skew to just know something a little extra. Will the number be positive or negative? The number will be positive. If you notice right here with skewness, it's a positive number. If the distribution was perfectly symmetric, the skew would be 0. So if it's right skew, we have positive skew. And that's what I'm pointing out right here by saying right skew is positive skew. A distribution that is perfectly symmetric would have a skewness of 0, and it's not skew. This is a symmetric distribution. So a symmetric distribution, if we drew one of these out, would have a skewness of 0. And I should be able to do that probably easier over here. If I go here to random normal, and I generate 1,000 random normal numbers. So this is for 320. They can see how we do this. Here's 1,000 random normal numbers. And watch this. Is my plot going to show up? Arrow is too large, that's why. So this is a normal distribution right here. I can regenerate this distribution multiple times and make just different random normal distributions. It'll look different each time because it's just random. These are random numbers making this. But let's just take one of these right here. This is not skewed, and we should have skewness. What package is skewness in? This is what happens when you restyle your R. Skewness in R function. So the skewness of this, where's skewness at? It is in the function E1071. Install packages, E1071. I reinstalled R recently, and when you reinstall R, you lose your packages. And I'll be doing that all semester, remembering that I reinstalled R. So we now have the skewness function. I just need to load up library skewness. This is why coding is awesome, because you can, library E107, and then the function in here is skewness. So what do you think the skewness of this distribution will be close to? Does this look symmetric or skewed? Symmetric or skewed? Does that distribution look symmetric or skewed? Does it look fairly symmetric or more skewed? What do people think? And great job, Emily, on the points right there. And that's silver tier. Nice job. Does that look fairly symmetric or more skewed? And that's, yep, exactly. This would be all you need to know for stat 1. That's all you need to know for stat 201. Like, if you say that's symmetric, boom, you know the concept. So the skewness, when I calculate it, it's going to be close to 0. There you go. It's very close to 0. And it's just, there's randomness around it. Like you see a lot of these are just close to 0. If you notice the last value I'm showing you on the screen at the very bottom down here is very close to 0. And I'm just doing different, like that one is super close to 0. It still has like a decently high outlier, but it's mostly symmetric. But let's change it from a random normal to a random exponential. And now, look at that. That has right skew and the pot number is positive. So, and I should be able to, let's times this by -1. If we do this, yes, now it's negative skew. So just seeing these two examples right here, you can see that this is a left skew distribution because the tail is pulled to the low side and has negative skew. And then let's just bring it back to what it was, where it looks normal. I mean, not normal, but where it looks right skew, and it's pulled to the right side, and we get a positive number. You don't need to know that right skew is positive. I just want to mention it because you could be in another class, and they could say positive skew, and you'd be like, what is positive skew? It's just to the right side. So the key concepts we need to know for stat 1 are right to the high, left to the low, whatever way the tail goes. That is skewness, and you guys got a little bit of a head start on the lecture right there, just kind of learning the material. If you know what's on this screen right now, you know everything there is to need to know about skewness. The bottom one is just called symmetric. There are non-normal symmetric distributions. Like that's symmetric, mostly. I didn't do it perfectly. That's better. That's still symmetric just because you can fold it over. It's a bimodal symmetric distribution. This one's unimodal. I could start talking about modality, but mode just means the most common area. So we have a little fun. We're just lecturing today. We're just talking about, like, can everyone see why this is called a unimodal distribution and this is called a bimodal distribution? Let's ask a crazy question right here. Anyone got any ideas what we would call a distribution like this? Like, let's say we have grades in a class and there's a group of people who make 80s. There's another group of people around 70, another group of people around 60s. So there's like concentrations of people in these areas. Like if we put a scale over here, we'd see like 0 to 30 people. Like in this area, there's like 30 or so people who are making this grade. Like there's a lot of people. Yep, you can say trimodal. Great job, Emily. Actually, Emily, that is amazing. You said it before I said it. Usually by the time we get to trimodal, we usually just say multimodal, but you could say trimodal. Trimodal is or multimodal, excuse me. Like this would be quad modal, but usually you just call it multimodal, meaning there's multiple modal areas, like multiple concentrations of data. So they're both multimodal. That one's trimodal and this one's quad modal, but I've never heard anyone say quad modal. I've rarely heard trimodal, but usually you just say multimodal. And I guess bimodal is technically multimodal, but usually people say bimodal. People say unimodal, bimodal, and then usually it goes to multimodal. So everything beyond one mode is, yeah. Does that make sense? I think we're good. I'm really, great job. Everyone, we're getting ahead. We've covered like 15% of a lecture, like just talking about these concepts. Hopefully they kind of make sense. Like when we use these words, like it's multimodal. Like what would, what two words would you use to describe this distribution? This distribution would be described how? How would this distribution be described? Exactly, bimodal and right skewed. Exactly. So it's because, and if we put a number line down here, so you can see it goes to the right side. So it's bimodal and right skewed. Exactly. I hear my neighbors. You're like hammering something. Make sure they know, like, I just joined, but could you explain right and left skew? Yeah, of course. When the chart's vertical, yeah, great question. Let's do that. Let's make a vertical one. So this is why I like right to the high, left to low. And thank you so much, Sarah. So if you look right to the high, left to the low, whatever way the tail goes, let's make a distribution, but let's make it vertical here. So we're going to change this number to 25. I'll put myself in here. I've played an instrument for 33 years. So there's me. Let's go analyze distribution and let's take a look at it. Okay, so here's the distribution. And if you look, it is vertical. Now, we have to draw our monster right here. I want you to envision the monster, and I want you to tell me which way does the monster's tail go? Does the monster's tail go to the high or the low side? So you have to, if you're wondering, what is Brian talking about seeing the monster? 2 seconds. Just gotta copy this. Okay, we're good. Oh, wait, zoom off. There we go. Okay, good. So what is Brian talking about by saying the monster? We're going to go ahead and grab this. Bring it over to a Word document. Drop it in. And let's see where the tail goes. So is the tail going to the high side or the low side for our monster? Is the tail going to the high side or the low side for the monster? So which way does the tail of the monster go? Which way does the tail of the monster go? The tail of the monster goes which way? To the high side or the low side? The high side. So right to the high, left to the low, whatever way the tail goes. Is this right skewed or left skewed? Right to the high, left to the low, whatever way the tail goes. Is it right skewed or left skewed? Which way does it go? Right to the high, left to the low. It is right skew. It is right skew. I think that the mistake a lot of people make is they drop the distribution like this. Now, why can't you just drop the distribution like this and say, this is what a lot of people do. They say, oh, it's left skew. What do you notice is wrong about this? Where people would say, oh, that's left skew, Brian, because it goes to the left side. What do you notice is wrong about this graphic? I should be able to fix it right here. What do you notice is wrong about this graphic? Because people say, Brian, that's left skew. You said right to the high, left to the low, whatever way the tail goes. What is wrong about this graphic right here? This is a common mistake. I think people be like, no, that's left skew, Brian. The numbers are opposite. Exactly. So you have to, you'd have to do it this way. And I know it's really hard to read those numbers right now, but now they're properly like from high to low. So it doesn't go from lowest to highest. Exactly. So it's actually reversed. So if you remember right to the high, left to low, whatever way the tail goes, if the numbers go to the high side, it's right skew. And I just see this very common mistake right here where someone takes this graphic and it's Control Y. I don't know how to redo other coding languages. But this goes to the high side. Does that help out right there, Sarah? Great questions and really good practice. You can also tell which way it's skewed by which way the mean is. This thing right here is the mean. This is the mean. And let's do, they changed the way this works. Let me add in another highlighter. I used to have multiple like pens, and then they were like, no, we're only going to give you 3 pens and 3 highlighters. They took away that you could pick your pens. This is the mean, and this is the median. Which of those, wait, so was this one, this is right skew. Good question, Sarah. This is right skew because it's pulled to the high side. This is right skewed because it's pulled to the high side. So this is right skew. Little monster dude. Pulled out, get big out of there. It's pulled to the right side. So this is right skew, right to the high, left to the low, whatever way the tail goes. It's pulled to the right side. No, definitely. It's so, we're just got a few people here right now. So be like, hey, wait a minute. I didn't catch that. Because it helps. Am I losing my mind? I think I'm losing my mind. Okay. So the median is right there in the box plot. It's the middle line in the box plot. So this is the median and this is the mean. What follows the skew? This will follow the skew. Like what, the mean or the median follows the skew? Which of those will follow the direction of the skew generally? Like there's weird examples we could come up with, but generally this follows the skew. Which of those follows the skew? The mean or the median? The mean is the average of all the numbers. The mean, exactly. The mean is the average of all the numbers, and the median is the middle number. So when you do the median, let's do a quick calculation right here. We have three numbers. Our three numbers are going to be, let's do 1, 2, and 87. Okay, so what is the median? What is the median here? What is the middle number? What is the middle number here? So the middle number is what? And if there was four numbers, we would average them together, the two middle numbers. What is the middle number here? 2. So 2 is the median. I chose 87 for a reason, because what is the mean of this data set? What is the mean of this data set? So what would be the mean of this data set? And I chose 87 for a very specific reason. So the median, the middle number is 2, and the mean is what? It's going to be all the numbers added up divided by 3. I chose 87 for a reason, because 87 plus 2 plus 1, exactly, Sarah. Great work, Sarah. Great work. So we just add up all the numbers, we divide by how many there are. So if you notice, when something is right skew, the mean is higher than the median because there's an outlier here. This data set's pulled out. We could kind of draw what this is going to look like. You'd have a thing with 2 observations right here, and then you'd have an extreme observation. So you'd have like 0 all the way to 90, and this would have your lower observations, and this would have 1, 2. Like we could draw this out and jump, but this is the kind of graphic you're going to see right here is 2 observations in the lower bin, and then a far observation. So it's right skew because it's pulled out to the right side. Just so you can see this in statistical software. And this is what I really like. It's really easy to go in here and just say, well, what would that look like? We've got here 1, 2, and 87. And then we draw it. And nice and easy, we can see. And we get a really weird box plot. But does this look like, right here, does this kind of look like, and I'll even add in the count access, and I have videos on how to do all these. But does that look somewhat similar to Brian's, this is what it should look like? Does that look at all similar? That's what I said it would look like, and that's what it does look like. So hopefully we're able to kind of, if we do a lot of these, we'll have a decent idea of like, okay, there were 2 observations, 1 and 2, they're going to be in the lowest bin. And then we've got the last bin. I did make one error. All bins are the same width. My last bin didn't look the same. But kind of thinking about how things will look like before you make the graphics a good way. Like then you understand what you're making. But this is very, very right skew. That is a extremely right skew distribution, mainly due to the outlier. What questions are there? We got 5 more minutes, but we did some really good topics today. We just kind of talked about some topics we'll be covering in class. And you're always free to come into office hours and ask, like, hey, Brian, I'm reviewing this. I'm stuck on this. So I really appreciate it. It's really, really good office hours. I'm out of coffee. I'm so out of coffee. Coffee. What last questions? PJ, good to see you here, PJ. Morgan and Sarah. Any last questions? Let me hop off to space right here. We are in space. Let's bring up the stat to 1. You know what I'm going to look for that music. I swear I had the right music on here, my sad music. I know where Pokemon is now. Not playing the Price is Right. Thank you so much, Sarah. Thank you so much, Sarah. Let me remove Price is Right, because if I play that, I get a copyright strike. There's the sad music. We're going to hear this twice, just because I love it that much. This is Josiah Wilkinson playing Coldplay. Never gotten hit with a copyright strike. And Josiah, hope you're doing well. Amazing pianist. So, and then we're going to remove Pokemon from here so I don't ever get copyright strike for Pokemon. We're going to play. There were 2 Pokemons. Let me save my soundboard so I remember. So that way we don't have the settings all crazy. Go to Profile. Go to Save. Copy. Create new. Save active profile. Overwrite. It is fixed. I will now know that we have our ending sad music here. It is the end of the stream, and I'm really, really proud of how everyone is working so hard. Everyone is just interacting in chat, here for office hours, saying hey. And with that, I'll be streaming later for BAS 320. I'll see you in class. Let me know if you have questions. I'll be replying to emails now. But as we always say, I love this music. Bye for now, everybody. Bye!